So hi everyone, let's start with today's topic. We are going to cover the probability basics. I have already promised you. So in basics, we are going to discuss about the three topics. First, we are going to talk about the basic concepts. Then we are going to talk about the permutations and combinations that are used in probability. And here I am going to discuss why the combinations are used for various probability problems, as I've already told you. And the third one we are going to discuss about the Bayes theorem. So I need you to learn the formula because it is basically used in various problems in the probability. So let's talk about the basic concepts. In the basic concepts, I'm just going to discuss about the continuous probability variable problem, and this continuous probability variable problem, how the probability concept comes. So let's talk about a particular area, say this area, and this area, shaded area, is what the ground we have in a field. Okay, and I want to find out, say somebody is playing here a match, cricket match. So if I want to find out the probability of a ball reaching in this area A1, and this whole area is capital A, so the probability for ball going in this area will be given by what? Probability for ball going in this area event is area of A1 divided by A. This is how you discuss about this probability, right? If you hit a ball in once. So this is how the basic concepts comes of continuous probability. This is continuous probability where we are discussing about the area. So let's come on to the basic concepts that I want to discuss today. So the most important concept is random experiment. So random experiment is an experiment in which the outcomes has to be among as the sets of events which are completely known. Okay, and but whose exact outcome is unknown. So exact outcome, random experiment का मतलब क्या होता है? The exact outcome is unknown. Okay, this must be the condition, because if you know the exact outcome, then the probability does not exist. Like मैं example देता हूँ कि if you throw a coin, so you know that the random outcome can be head or tail. But if you know for sure, say the coin is not unbiased, if the coin is biased, so it have head on both the sides, so you are sure that the probability of this event for being head is 1, right? Why? Because it has heads on both the sides. So this type of experiment cannot be called a random experiment. For random experiment, there have to be outcomes which are not known beforehand. Okay, so this is the random experiment means. Now let's move on to sample space. As you already know, as this is the sample space, entire area is the sample space, right? Now what I'm going to discuss about, most important part here, is mutually exclusive events. So generally you have heard about this mutually exclusive events. So what it is, I want to keep you in mind, right? So I will tell you with example. So mutually exclusive events are those, let me write it. Okay, so mutually exclusive events are those in which if one event has happened, right, if one event has happened, then other event will not occur. Like if you throw a coin, so let's talk about a coin, right? So in mutually exclusive events, you always remember this example, then you will remember this, what is mutually exclusive event. So if you throw a coin for once, only for one time, right? If you throw a coin only for one time, and then you know that if the coin comes out to be as head, then you know that the tail is mutually exclusive of the head. Why? Because if head comes, then tail will not come. Definitely, as there is only one outcome of this, so only head will come, tail cannot come simultaneously. So this is mutually exclusive. These two events are mutually exclusive. So this is how you describe the mutually exclusive events. Okay, and similarly you talk about dice. If you have a dice, say like dice like this, and you throw that dice and you get a 6 on the top, you know that the 6 is mutually exclusive of others numbers, right? So if 6 has come, then another number 5 cannot be on top, it have to be on some other place. This is mutually exclusive to this. And just similar definition, but a little bit difference is there if I talk about independent events. And this type of events must be considered more about, because we are going to talk about this type of events in our formulas, right? Independent events. So I want you to remember only two, rest you already know by Venn diagram. So independent event is an event which is described as such that if the occurrence of an event has no effect on the probability of occurrence of the another event. Means if probability of P, let's say we have two events, E1 and E2, then probability of occurrence of event E1 have nothing in common with the probability of occurrence of event E2. This must come out as 0. So I can show you with Venn diagram that this E1 and E2, these are not independent, right? Why this is not independent? Because these have a common area. So if event E1 has occurred, so this part of event E2 have already occurred. So I am talking about the intersection of these two have to be 0. Here the intersection is not 0. Therefore, this is not an independent event. This is not independent, right? So I think you have understood it. So what are independent events? Independent events are those in which, if you talk about the probability for independent events, so it can be easily expressed as, you must understand this part, the probability of occurrence of event P. So I'm sorry, probability of occurrence of event E1 with the probability of occurrence of event E2. I'm sorry, here there is something mistake. This is not probability, this is the area. So area of event E1 cannot have any intersection with event E2. So this is not probability I'm talking about. For probability, for intersection of the two probability is equal to product of the probability of one event with that of the other event. So this is equal to that. So this is what you have to understand. This have to be 0 and this have to be product of the two. So this is how we express the independent events, right? Independent. So if the two events probability, the intersection of both the events, that is both the events occurring together, is equal to the product of the probabilities of the two events, then it is then the events are said to be independent. Okay, and the rest is not much important. So we are going to talk about the use of permutations and combinations in probability. So generally in the problems that we see, so we see the combinations are used. Why the combinations are used, that I am going to talk about here. So let's see, we have three spaces and we want these spaces to be filled up with two heads and one tails. So we have three spaces and we have two heads and one tail. Okay, so this considered to be a coin is tossed three times, and one time there have to be a tail and the other two times there have to be head. So we want to find out the number of ways these arrangements can be made. So let's not go to the permutation and combination, let's go to the basics. So if these arrangements required to be made, these have to be like head tail, or head tail head, or tail head head, right? So we have three ways here. Now let's talk about how we obtain to this part. So let's talk about basics. So it is equal to, if you arrange three letters, so how it comes out to be 3 factorial. But you see there are two letters which are same, so we have to divide by 2 factorial. This is the number of ways. So this comes out to be 3, and this also equal to 3c2, right? This also equal to 3c2. And will permutations can be used here? No, permutations cannot be used here, because in such events, this is a small event. If you talk about bigger events, let's talk about arrangement of 5 spaces. So permutations, if you use a permutation here, say if you use a permutation in this case, if you use 3p2, then the answer will be 3 factorial divided by 3 minus 2 factorial, that is equal to 6, and the 6 is not the correct answer. So this is wrong answer. Why this comes permutations? Why this comes wrong? Because permutations, what it gives is, it gives the arrangements, a number of arrangements possible, but it don't considers the repetitive words. That's what the case in the combination, it considers the repetitive words, and that's why this is used in the probability. So you can understand from this simple example why combinations are used, because this gives the answer of this number of ways that the arrangements can be made, and repetitive parts are considered here. So I think you have understood why the permutations and combinations are used in the probability and the combinations are used. So let's talk about the Bayes theorem, third part. So we are going to talk about the Bayes theorem. So Bayes theorem actually talk about, I want you to remember this formula, and regarding the Bayes theorem I will discuss with examples. The formula for Bayes theorem is PE, probability of occurrence of an event if an event A has already occurred. This is what formula we use for Bayes theorem, कि if event A have already occurred, this is conditional probability, and I think you know about the conditional probability. It is how it is told. It is said that probability for occurring of event E if A have already occurred. A have already occurred. So how can we see this in the form of a Venn diagram? So let's say this event is n sample space, and this event is A. So this event is A, so we are going to talk about probability of occurrence of event E. So let's say this is E. So if A have already occurred, then we are going to talk about the probability of occurrence of event E. So this is what we call the conditional probability. Since A have already occurred, so the entire sample space is now insignificant, because now A becomes a sample space. So this is how you understand the Bayes theorem and this conditional probability. The Bayes theorem is PE by A. You have to remember this formula. इसको यहाँ पे आगे जाके उल्टा कर देना है, तो P A by E इंटू ये जो नीचे में है उसको मल्टीप्लाई करना है PE. ये कैसे आएगा मैं आपको बताऊंगा बाद में. और यहाँ पे बोलेंगे टोटल प्रोबेबिलिटी. अब देखिए जो नीचे आ रहा है ये कैंसिल हो जाएगा ना, PA बचेगा, राइट. तो हमको वही चाहिए था. अब हमको यहाँ पे क्या करना होगा, क्योंकि यहाँ पे PE बाई टोटल ऑफ A है, तो यहाँ पे टोटल PE चाहिए नेट. अब ये कैसे आएगा, ये होगा समेशन. दिस इज द टोटल प्रोबेबिलिटी फॉर द अकरेंस ऑफ इवेंट E. Sorry, for total probability of event A. So this whole will be the probability for the event A for which the E have already occurred, and this is the total probability for event A, that is equal to probability for event A if E has already occurred. So it will be written as PA by E into PE plus probability of event A if E2 have already occurred into PE2. So let's say we have two events E1 E2. So this is how it is written, the total probability. So first I want to you to remember this formula, and we will discuss about the use of this formula and how this formula comes in the later on with examples. So this is called a total probability. I want to remember, like इसको रटना बहुत ज़रूरी है, because you have to remember this formula. That's why I am going to discuss in this basics video, and later on I will discuss about the concept behind this formula. So आप इसको रट लीजिए, PE by A is equal to PA by E. यहाँ पे उल्टा हो जाएगा, और जो नीचे है उसको यहाँ पे लाके क्योंकि काटना है हमको, तो डॉट PE डिवाइडेड बाई PA, क्योंकि यहाँ पे A है तो यहाँ पे PA आएगा. ये टोटल प्रोबेबिलिटी ऑफ A इवेंट. कैसे प्रोबेबिलिटी ऑफ A, तो यहाँ पे प्रोबेबिलिटी ऑफ A इवेंट कैसे पूरा निकालना है वो मैं अब बता दूंगा आपको बाद में. तो यहाँ पे देखिएगा प्रोबेबिलिटी ऑफ इवेंट E अकरिंग इफ A हैव ऑलरेडी अकर्ड इज इक्वल टू प्रोबेबिलिटी ऑफ A अकरिंग इफ E हैज़ ऑलरेडी अकर्ड, and this is into probability of event E divided by total probability of event A. So this is the Bayes theorem, and this is also called the reverse probability. Reverse probability, and how it is called reverse probability we will discuss in the next video of probability. Okay, so be updated with our next video. Thank you and goodbye.